Hi there, this is GCSE Physics, Electricity, Lesson 11, Thermistors and LDRs. By LDR we mean light-dependent resistors. The objectives are to describe how thermistors and LDRs work and to complete some examination-style questions. The resistance of a light-dependent resistor is not fixed, it is dependent upon the intensity of the incident light. So here's an LDR symbol. So an LDR has high resistance in the dark, but a low resistance in the light. So there's a graph of resistance on the y-axis against light intensity on the x-axis, and as you can see, as the light intensity increases, the resistance of the LDR will decrease. So the graph shows how the resistance of an LDR decreases as the light intensity increases. This means that LDRs can be used in light sensing circuits because their output is dependent upon light conditions. Let's move on. So the thermistor now, the resistance of a thermistor varies depending on temperature. So here's a thermistor symbol. So it has a high resistance when cold, but a low resistance when hot. So again, the graph, which is essentially the same shape as the LDR graph, so we've got resistance on the y-axis against temperature on the x-axis. As the thermistor gets warmer, as the temperature increases, the resistance will actually drop. And this is unusual, as resistance normally increases with increasing temperature. All you've got to do is think back to a standard metallic conductor, or a good example would be the filament lamp one. You know, as the graph curves, as a bulb increases in temperature, the resistance will increase. But a thermistor is the other way around. So thermistors are useful in the sensor circuits of a thermostat, as their output varies with temperature fluctuations. Thermostat is the device that controls temperature in your house or in a place of work or a school. Okay, let's move on. So once you do these questions, so there'll be a couple of questions, 3 slides in total. So pause it, attempt the questions, and then I'll take through the answers. So the diagram shows a temperature sensing circuit used to control a heating system in a house. What quantity does the ammeter measure? So ammeters obviously measure the current. The current in the circuit is 3.5 milliamps when the potential difference across the thermistor is 4.2 volts. Calculate the resistance of the thermistor. So that's V equals I times R. Now if you've got good math skills, you can just rearrange resistance is voltage divided by current, and then put the numbers in. If not, we can put the numbers in, which I'll do now. So 4.2 volts equals the current. So 3.5 milliamps, we need to turn that into amps. So we need to divide that by 1000, which is 0.0035 times R. And then to get R on its own, we need to get rid of the times 0.035. So we get 4.2 divided by 0.0035. And that will give us the resistance, which is 1200 ohms. Hopefully that went okay. Let's move on to the next one. So if you want to pause and have a go at this one. So this one's relatively straightforward. So we want charge and we've got current, 3.5 milliamps, and we've got the time of 5 minutes. So the equation we need to use is Q equals IT, which is charge is current times time. Then we just need to put our numbers in. So Q equals the current, 3.5 milliamps, which is 0.0035 multiplied by the time. Now 5 minutes, we need to do 5 minutes times 60 seconds, so that gives us 300 seconds in total, times 300, and that gives us, so we need to do 0.035 times 300, which gives us a total of 1.05 coulombs. Okay, let's do one more. So you want to pause and have a go at this one. So D, explain why the potential difference across the thermistor changes as the temperature in the house decreases. So we need to explain how it changes. So what will happen if the temperature in the house decreases? If you remember the graph, so we had resistance against temperature, looks something like this. So if the temperature of the house decreases, goes that way, the resistance will increase. So the resistance of the thermistor will go up. So that's the first part. And then we need to explain what happens to the potential difference. Well, if there's more resistance, if you look at Ohm's law, V equals I times R, the current's the same through each part, through this one and this one. So if the resistance is increased, that means that it will need more voltage across the thermistor. So we could say something like temperature decreases. So when the temperature decreases, the resistance of the thermistor, increases, which means it will require a larger voltage share. Remember, back to circuit rules. So the voltage of 9 volts will share equally across these two, the 2000 ohm resistor and the thermistor. So I don't know, maybe we could figure them out, but the values essentially will always have to add up to 9. So if the resistance across the thermistor goes up, the voltage share will go up, which means that the 2000 ohm resistor will end up with less voltage across it. But the answer given here should be suffice. So next one. The circuit shown in the diagram can be modified to turn lights on and off by replacing the thermistor with an LDR. Draw the circuit symbol for an LDR. Well, that was given to us earlier. And it's basically a resistor with a circle around it and then a couple of arrows. So that one should be okay. Anyway, that's the end of that video. I hope you found that helpful. Thanks for watching, and I'll speak to you soon.